down. I think that's funny. We'll talk about our 8-2 notes. We already talked about most of this front page last week, but I'll give you a little recap so I can make sure we're all on the same page and we're all looking at the same idea. When we have rectangular coordinates, we usually write them as an X and a Y. We put them in a parentheses like that in an ordered pair with a comma in between. And if we were to do something like an example 4, 1, we could easily graph that by moving over 4 units and up 1 unit, and we would have a point right here at 4, 1. That's okay. Our polar coordinates are written in a different manner. They're written in brackets with a radius and an angle, a theta. And we use brackets instead of parentheses. Now, we talked yesterday about how this is like looking at the pole of the planet, like looking straight at the planet right on top of the North Pole or the South Pole, and how it's like the unit circle. So I'm going to put that idea here. It's like the unit circle, but we're changing the radius. So it's like the unit circle, we're just changing the radius. We're no longer locked in with a radius of 1. We have different radii that we can use in different values. Now we're going to follow just a couple rules about how we're going to graph these things on this polar grid. And I do have polar graph paper up at the front. When you guys start doing your homework for assignment 2, you'll probably want to grab a couple sheets of that graph paper and just have it. Otherwise, you're going to be drawing these kinds of coordinate grids a whole bunch. That's just easier if you have those ones to begin with. So we have our theta, and if our angle is positive, we would start here like this and we would move our angle upward like that. If our angle is negative, we would start with it crosswise like this and move it downward. Most of us remember that from algebra, algebra 2, and geometry. Now if the radius is positive, we're going to move towards the tip, and I do it just like having a pen or pencil that you're going to use. So if you put the center of your pen or pencil right in the center of the coordinate grid, the first step is always to set our angle measure, so whether it's positive or negative. And then the radius, we're going to count outward from the center. And if it's a positive radius, we're going to move towards the tip of the pen or pencil. If it's negative, we're going to move kind of towards the eraser end. So you'll hear me refer to it that way, moving towards the tip or the eraser. All right. The best way to look at these, though, is, of course, to just look right in and dive on some examples. So let's see, pi over 6. Who can help me out? What is pi over 6 in degrees? What is that? 30. Awesome. Pi over 6 is 30 degrees. We're still not off the hook with that unit circle. We're still going to keep on using that same information again and again. So pi over 6 is 30 degrees. So my first move is to go 30 degrees up. All right. So I'm going to start with my pen here right in the center. I'm going to move it so that I'm 30 degrees upward like that. And then since my radius is 2, I need to count 2 rings outward toward the tip of my pencil. It's going to be right about here. So go ahead and put a point there, and we'll call that point A. So I went 30 degrees up, and then 2 towards the tip of the pencil. My example B tells me I'm going to do the same angle, but -2. So I'm going to again put my pencil right in the beginning, 30 degrees upward like this, and this time I'm going to move 2 units, 2 circles outward toward the eraser end of my pen or pencil. So I see, let's see, I'm on this same angle here, count out 2 going towards the eraser end. Point B is going to be right there. So we went 30 degrees up, and then 2, bless you, 2 toward the eraser. And we're going to see that these can also be in degrees, so we do have radian and degree modes that we're thinking of. This next one says we start here, we're going to move -120 degrees, so I'm going to move downward 120. That means I'm rotating my pen right about till here on this line. And then from the origin, from the center, I'm going to move 3 towards the tip of my pencil. I'm going to be down in quadrant 3. I count out to the 3rd ring right here, so there's point C. So we went 120 degrees downward and then counted 3 toward the tip. One last example. Yeah.
How did you count to 120 and get how you got?
Oh, okay, how I got to that negative 120. In this unit circle, each one of these lines is 30 degrees. And I could just tell that just by seeing kind of what it's counting by. So that's 30 degrees, 60 degrees, 90 degrees. So if I'm going negative 120 degrees, I did kind of breeze past that, didn't I? Down here would be negative 30, negative 60, negative 90, and negative 120. So I knew it had to be on this line somewhere.
So it just reflects at the top. Like if you just had like a regular grid, you reflected it because 120 would be the same as you reflected.
Right, 120 would be up here. Yep. So I just needed to go downward 120. So instead of rotating it up here, 120 degrees up here, I'm just going to start at the same place. I'm just going to rotate downward. Okay. So rotating it negative 60 degrees means I'm going to take it 60 degrees downward. Since each of these lines is 30, this is going to be my line for negative 60 degrees down here. Oof, make that degree symbol smaller. Sorry about that. That's negative 60 degrees. And then with my pen facing down like that, I need to move 4 units towards the eraser part of my pen. 1, 2, 3, 4. It looks like it's going to be that outermost circle, and that's part D, point D. So now that we've seen how we can identify these points, we can label them, we can turn coordinates into graphs, we also need to be able to go right from rectangular coordinates to polar coordinates. We're going to see transferring them both back and forth. We see on our window our big ideas for this chapter is that not only are we going to be able to graph rectangular, complex, and polar coordinates, we can also convert among them pretty nicely. So we're going to see how we can first of all convert from polar to rectangular. We want to go from a radius and a theta in polar form to rectangular form, x, y. So being able to convert from one to the other is going to be our main goal for this little part of our unit, our notes here. So if I think about the unit circle, any point that I had that was an x and a y on the unit circle, we would have a line that would be a certain x and a y out from there. And on the unit circle, our radius was always 1. We had an x and a y. One of those was sine and one was cosine. Do you remember which one x was? Awesome. Our x is a cosine value. Our y was sine. That's good to know because all we're doing now is taking this same info, so we've got our same idea, with any radius value. So instead of this now just being a radius of 1, we can possibly have a radius that's way out here like this. And we're still going to have an x and a y coordinate. Alright. So to change from a radius and a theta to an x and a y, here are the 2 equations that we need. Our x, instead of just being cosine of our angle, is going to be the radius times the cosine of the angle. You see how it's the same, we're going to have the same ratio of values going on for that sine or cosine based on our angle measure. It's just the length that we're moving, that we're changing. You want to take a guess what our x is going to equal? If our x was radius times the cosine of the angle, what do you think our y is going to be? r times the sine of the angle. There you go. R times our sine of the angle. And we do want to say that we're going to say exact whenever possible. We're going to keep these values exact if we can. But I'll show you how we can always check our answers, because that's always a good thing to know. So I have a polar coordinate, 3, 5 pi over 6. Let's go ahead and graph where that is first of all, so we get an idea where we're looking. So I rotate 5 pi over 6. I'm going to move to the third circle out. We're looking at a point right there. We're in quadrant 2. It's good to know. Radian mode tells us we're going to find our x by doing the radius, 3, times cosine of our angle, 5 pi over 6. Let's go to our calculator and see what we're looking at. Let's make sure we're in radian mode. And when I do cosine of 5 pi over 6, I don't want to just go ahead and immediately multiply it by 3, because this is the number that we know. I'm not going to write down negative 0.866. What am I going to write down as the cosine of 5 pi over 6? Awesome. Negative root 3 over 2. So our x value equals negative 3 root 3 over 2. This is our exact value. Now I kind of want to get an estimate about what that would be as far as a decimal. So if I take this answer now, remember that's our cosine, I need to multiply it by 3. And I'm going to see that it's approximately equal to negative 598. We'll go ahead and take it out 3 decimal places. So that's our x value. Let's see what we have for our y coordinate. Again, it's that radius, this time times the sine of 5 pi over 6. Sine of 5 pi over 6 is looking like 1/2. That's awesome. Positive value. So we're looking at 3/2 or 1.5, either way. Now let me show you how we can double check this on our calculator, or how our calculator can do it for us if we don't mind inexact decimals. Find your apps button. Do you see your apps button right here on your calculator? We don't want to hit the apps button. We want to hit second apps. It's an angle menu. So hit second apps. Should pull up this angle menu. So we have degrees and minutes and radians, and you can turn it something to degrees, minutes, and seconds. But here, 5, 6, 7, and 8 are the things that we're going to be using for conversions. Since we're going from polar to rectangular, we would use numbers 7 and 8. Do you see how it's telling us it's going to turn the P into the RX and P into RY? We have to calculate our X and Y coordinates separately. It's going to take us 2 steps on our calculator to do it. But I'm just going to go right down there to number 7. I have a polar coordinate. I want to turn it to rectangular. I'm still in radian mode. I'm going to push 3, put a comma there. That comma is right next to your parentheses. 3 comma 5 pi over 6. And then hit enter, and it tells me the exact same decimal that I found over here. There's my x coordinate. Isn't that neat? Let's try it again with our y coordinate. 3 comma 5 pi over 6 and then hit parentheses, and you'll find your y coordinate is 1.5. So we've got a nice way that we can double check. Remember, we're going to be exact whenever possible, but if you want to go ahead and try it on your calculator and you're finding that it's 1.5 here, that is exact. We're set to go. So if we continue, we're going to see how we can turn from rectangular into polar. And our rectangular coordinates are x, y. We're going to learn how we can convert those into our into our polar coordinates, r and theta. Now I'm going to go ahead right on back to that idea of a polar coordinate being some kind of point out here. And what we have is a radius and an angle. That's what we're given. Well, if we have, I'm sorry, we're given an x and a y. Ooh, my last ones we were going from polar to rectangular. So we're given an x and a y. This is what we start off with. Let me put that in blue. If we start off with an x and a y value, we start off with our rectangular coordinates. To find the radius, you can see that we're going to just be using Pythagorean theorem. We're going to make a triangle using Pythagorean's theorem. So we're going to be using x squared plus y squared equals r squared. Or if you want to get r by itself, we're looking like this. R equals the square root of x squared plus y squared. And now if I know an x and a y value and I'm trying to figure out what theta would be, well, let's see. Theta is a relation of x and y using our tangent trig function. So we would have tangent of our angle would be opposite over adjacent, y over x. That's what we have right here. But getting theta by itself, we would just be doing inverse tangent of y over x. Let's see what this would look like. Doing one example here. I have a rectangular coordinate, -3, 4. Let's graph that first, get a sense of where we're looking. 1, 2, 3, 1, 2, 3, 4. We're looking somewhere up here in quadrant 2. So we'll find our angle. Tells me I need to do inverse tangent y over x. My y is 4. My x is -3. I'm going to do this in degree mode, so put yourself into degree mode. Inverse tangent 4 over -3. I'm getting a -53.13 degrees. So my theta is approximately equal to -53.13. My radius, using my equation up here, is the square root of x squared, -3 quantity squared, plus y squared, 4 squared. Square root of 9 plus 16, square root of 25. What is the square root of 25? 5. What's the other square root of 25? All right. So what we're seeing now is that we have to make a decision. We have to stop and think. Because if we need to figure out if our radius is going to be positive or -5. We don't know which one. We need to look at our picture. So since -3, 4 is up here in quadrant 2, if I'm moving my angle at -53 degrees, I need to get up here to this point. Does my radius have to be positive or negative for me to get there? Negative, fantastic. So what we're looking at is a radius of -5 and -53.13 degrees. Now skip down with me down below because I want to show you this part. Keeping with that same answer, that -5 and -53 degrees. We can rewrite that in multiple ways. If I start with -5 and -53 degrees, I can add 360 degrees to it or subtract 360 degrees. So if I add 360 degrees, I have a negative number. I'm going to end up with a coordinate set of -5 and 307 degrees. Same point if I were to graph or plot these things, but now I can just write this with a positive angle measure instead of a negative. I also can do it by changing this to a positive radius. If I have -5, -53 degrees, if we picture this, instead of me moving my angle downward like this, What if I wanted to, instead of it being down like this, what if I wanted it to be a positive angle measure and get to this point with a positive radius? You see what it's looking like I need to add to it? I'm going to be adding 180 degrees. And when I do that, I get 127 degrees. But now my radius would be a positive value because I'm rotating to a positive angle measure up here. So I can also rewrite this as 5, 127, keeping this radius positive. So our big idea is if we rotate 180, our R changes the sign. If we add or subtract 360, our radius stays the same.